right, continuing with the last part of 3.12, and this would be part 4. Consider what you've learned about rigid transformations. Would a series of rigid transformations preserve the area of a polygon? That is, would the area of the image always have the same area as the original polygon? Why or why not? So in this case, we said yes, right? Yes, it preserves the area since we're just moving the object in space, right? Since we are just moving the object in a plane, actually. All right. So if two polygons have the same area, are they always the image of a series of rigid transformations? So just because two polygons have the same area doesn't necessarily mean that both of them have pretty much are a series of rigid transformations, right? Because I can have pretty much like a square with an area of 100, right? 100 square units. And then that would be just 10 by 10. And then I can also have a rectangle, right? A rectangle, a 5 by 20 rectangle, and that would still have an area of 100 square units, all right? So just because I have the same area doesn't necessarily mean that I can always just assume that they're the same shape, all right? So we got to be careful with that. And then it says verify your answer in part A by calculating the areas of the polygon and triangle ABC, EFG, and the triangle E double prime in problem 315. Then calculate the areas of both the original block L, problem 315, and its image. Do any of the rigid transformations change the area of the figure? So if we go to question 315, right? So at first we have this triangle. So on this one, again, remember, find the area of a triangle. We have, this was our original image, right? And then it got reflected over here. Right there. This was the F prime, G prime, E prime. And then that one got reflected on this side as well. And that was E prime. That was G right here. This is E prime. And then this is F prime. So the area for this one right here, we have pretty much 1, 2, 3, 4, 5, 6, 7, 8. So 1/2 base times the height. So the area of the first triangle right there, 1/2 8 times the height, which would be right there, which in this case is 3 units. So times 3. Half of 8 is 4, times 3 is 12. And then for this triangle, let's do it in blue now. For this triangle, I have the area is equal to 1/2. Again, in this case, the height, we can just look at this would be the base of the triangle, same thing. So 8 times 3, the height is 3 again, so that gives us again 12, right? So again, this confirms part A, the area. This one's a lot easier if you guys just count, right? The little squares. You'll figure out that we have 2, 4, 6, 8, and then plus 8. That gives us 16 in total. And then here we have 8 here, and that again is 16, right? So again, the area is always preserved. The area is always preserved, right? In rigid transformations. All right. And then pretty much right here, let's say decide which transformation was used on each pair of shapes. Some may have undergone more than one transformation, but try to name a single transformation if possible. So what do you think is for part A right there? Reflection, a translation, or a rotation? I would say reflection. All right. For B, again, what do you think it is? Reflection, rotation, or translation? I would say translation, right? In this direction, if you notice. So this is translation. For C, what do you think it is? Reflection, rotation, or translation? To me, this would be like a rotation, like around over here. So rotation. All right. For D, rotation, translation, or reflection. So this looks like a rotation again. And then for E, this looks like a reflection. Even your line could be right there, right? So reflection. And then finally for F, we could say this ended up over here, right? This ends up down here. So I would say this is more than one, right? Because it looks a little bit weird. So it looks like a reflection and a rotation.